equations in slope-intercept form. And then we graphed each one of these lines. And in this problem, the lines happen to be the same line, so it was infinitely many solutions. Okay. Couple of things you had to be aware of. Graphing lines, graphing line method for solving systems of equations. If I have x equals a number, what kind of line do I have? Vertical. Vertical line at x equals 4. You guys are going to need your rulers again, aren't you? If you didn't do it. So I have a vertical line at x equals 4. And then the horizontal line was y equals a number, right? So you had to be kind of a couple of little tricks with those. So y is -2. So the answer to this problem was, yeah, where they intersect was 4, -2. And actually, that makes sense because my x value is 4, my y value is -2. And you would just do that with the different types of problems. Like number 5, remember, it's y equals mx plus b. What's my b in the top equation? What are we adding to the? Well, that's my slope, right? Slope is 2/1, but what's my b? Yeah, we're adding 0 to this. So we would start at 0, go up 2/1, up 2/1. And if you want to keep putting a whole bunch of dots here, a lot of times, or I can go down to the left one. It helps when you're doing the intersection point, when you're trying to find the intersection point. And then the second equation, what's my b? -3, right? And what's my slope? 3/1, the coefficient of x. So here we start at -3. I'm going to go up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. There's my intersection point right there. 3 to the right 1. See how sometimes these are really hard to get? Point of intersection is 3, 6. Point of intersection. But that's what we did yesterday. Questions? Are you bored? Or you just know this stuff like the back of your hand, right? Don't even have to do any more. What are you watching? Didn't they start a new series with that? Yeah, Gotham, the Dark Knight. Okay. All right, so let's go on to 6.2. Solving. You see, I'm up on things. I'm not as old as you think. 6.2, solving systems of equations by substitution. Here's the second method, substitution method. This is in your note packet, right? Yeah. So you're back at your note packet. Here's the process of the steps solving by substitution. Step 1. When necessary, you have to get one of the variables by itself. Most students are used to getting y by itself, but there are times when you can getting x by itself might be easier, so be careful with that. Step 2, substitute the resulting expression from step 1 or whatever. When you get the variable by itself, whatever that's equal to, you're going to substitute it into the other equation. Okay? And then you just evaluate it. Here's a problem that students have a tendency to make, is a mistake. They forget to find both variables because you have to go back in and plug it in. Okay? So let's look at an example. This one, example 1 is done for you. Let's go to, let's do 1A. Okay? Now, step 1, do we have a variable solve for? Why, yes, we do. The y is by itself, correct? In fact, y equals 4x minus 6. So what we're going to do is substitute it in the other equation where the y is. Okay. So I have 5x plus 3. Now, for the y, I'm just going to put in a set of parentheses. And that equals -1. What does y equal again? 4x minus 6. Now I have an equation with only one variable. All I have to do is solve for x. Okay. 5x, I have a number in front of parentheses, so I have to distribute that 3. So 3 times 4x is 12x. 3 times -6 is -18. Equals -1. Solve for x. I have x's on the same side of the equal sign, so I'm going to combine like terms. So I get 17x minus 18 and -1 on the right-hand side. Get my numbers on one side and my variables on the other, so I'm going to undo minus 18. I'm going to add 18 to both sides. Now, those of you who know how to do this, you could, start on the homework, obviously. I know we have all different levels here. Bring down your 17x. -1 plus 18. Positive 17. Then we have to divide by the coefficient, 17. And what does x equal? Yeah, x equals 1. Now, remember what I said. Because I got an x equal a number, we know that it's going to intersect at one point. Remember, we have those 3 conditions that it can happen. Infinitely many, no solutions, or exactly one point. Since x equals a number, I know my solution is going to be one point where my x equals 1. Now, when you have exactly 1 point, you should put it in ordered pair. We have to go back and find y, though, right? You can pick either equation. In this particular instance, y equation is going to be easier because the top one, because y is solved for. We know that the x is 1, so we're just going to substitute in 1 for x. You with me? Times 1 is 4 minus 6. So y is going to equal 4 minus 6 is -2. So this is my answer. They intersect at one point, and that point is 1, -2. Let's do another one. Let's do the next one. 1b. See, I have y solved for already, so I don't have to solve for a variable. Y equals 3x plus 10. So I'm going to substitute it in the other equation where the y is. So I have 2x plus 5, and for the y, I'm going to put a set of parentheses, equals -1. And substitute in 3x plus 10 for my y. Going to solve for x now. I have my 2x. Have to distribute the 5. 5 times 3x. 15x. 5 times 10 plus 50 equals -1. Combine our like terms, 2x and 15x, 17x, bring down our plus 50 equals -1. Undo the plus 50, so I'm going to subtract 50 from both sides. I get 17x equals -51, and I bet you 51 is divisible by 17. Divide both sides by the coefficient 17. So my x is going to equal, let's see, I have a negative divided by a positive, so it's going to be -3. Good. So I know this is going to be a point where my x is going to be -3. Okay, pick an equation. I'm going to pick the bottom one. Y equals 3x plus 10. And I know that x equals -3. So 3 times -3 plus 10. 3 times -3 is -9 plus 10. It's going to give me +1. Let's do one where we have to solve for a variable first. Any questions on this? You good? I see people writing. I don't know if they're doing their homework or still taking notes. Okay, look at turn it over. Look at 2b. Now I don't have a variable solve for. I don't have a variable on one side of the equation and everything else on the other. Looking at the variables here, we have x's and we have y's in both equations, right? Just looking at this, what do you think, which variable is going to be easiest to solve for? The x, because it has a coefficient of 1. So we're going to take this x minus 3y, take x minus 3y equal -9, and let's solve for x. Okay. I'm going to add 3y to both sides. Okay, that gets my x by itself. And I'm going to put my y term first. I don't have to, but I like my variable term first. So this is what x is equal to. Now we have to be careful. Okay? We're not going to substitute it in for y. We're going to substitute it in for x. So I have 5. My x is being substituted, so there's my parentheses, minus 2y equals 7. And my x is 3y minus 9. Now this time I solve for y. Okay, 5 times 3y, 15y, 5 times negative 9, negative 45, minus 2y equals 7. See, we have some terms to combine. We've got a 15y minus 2y gives me 13y, good. And I've got my minus 45 equals 7. Undo 45. Add 45 to both sides. So I get 13y equals 52. And I bet you 52 is divisible by 13. It's 4. Okay, so I got y equals a number. So I know that this is going to intersect at a 1 point, and I know that the y is 4. So now I'm going to pick an equation. I'm going to go back and pick one of the original ones. I could use this one, but what if I made a mistake? Okay. So I'm going to go back and pick the top one. X minus 3y equals negative 9. Be careful. This time we're substituting 4 into the y. Okay. So I have x minus 3 times y, which is 4, negative 9. So I have x minus 12 equals negative 9. Undo the minus 12. Add 12. So what does x equal? Okay, positive. Here's my. So these can get pretty lengthy. Any questions? Comments? We need to do a quiz next week on 6162. You guys are awful quiet today. It's a good thing. No Burgess, no Matthew. Your homework then. Notice that we get remember I have 3 conditions, or 3, I can end up with 3 solutions. Exactly 1 point, no solution, or infinitely many solutions. Okay, so this could be one of 3. Exactly 1 point, infinitely many solutions, or no solutions, right? Now, when it's 1 point, what kind of answers did I get? I got a number equal a variable. So here I had a number equal a variable. If I have a situation, and all 3 of the examples were this way. If I had a a problem where I had infinitely many solutions, what I would have is I would have the same number equal the same number. In other words, something like 4 equal 4, 3 equal 3, -1 equal -1. That's infinitely many solutions. You know, instead of y equals a number, instead of like y equal 4, I would have -1 equal -1. Now, if I didn't have any solutions, I would have something that's not true. Like 4 equals 0, 2 equal 1. Okay? Then your answer would be no solution. Does that make sense? All right. You have quite a bit of time. You've got like almost 20 minutes to do them. You should be able